Hello, welcome back for learning all about Backsolve. Let's do it. So Backsolve is basically the technique where we work off the answer choices, basically just trying them out and seeing which ones work. This can work on so many different kinds of problems on this test, but the big difference from plug-in is here it actually matters what the unknowns are because only one of the answer choices will be correct. So let's take a look at this guy. Very often we might solve a problem like this using a system of linear equations. So let's give this a read and I'll show you how that looks and then I'll show you how to completely avoid it. So Gary or Jerry or whatever his name is, age is 5 more than 3 times Carol's age. If the sum of their ages is 45, how old is Carol? So we're going to say, how old is Carol? This is what we're looking for. It's very important to remember that whatever we're looking for, that's what the answer choices represent. The answer choices represent how old Carol is. Carol is 10 or 12 or 14 or 16. Now in this situation, we would never plug in random numbers for Carol's age. Like I wouldn't just pick 7 for Carol's age. Why? When we look at the answer choices, I can guarantee you her age won't be 7 because 7 is not an option. So why not just work off the answer choices? But before I do that, I'll show you with algebra, and then again, we'll figure out a way to get rid of it. So if I'm going to translate that first sentence into algebra, I might use G for Jerry's age and C for Carol's age. Highly recommend if you're plugging in variables for names or things in a question that you use the first letter to help you remember what it is that that's representing. Using X and Y is more traditional, but this will actually help you keep things straight a little bit better. So I might say something like in math, Jerry's age is equals 5 more than, we're going to increase by 5, 3 times Carol's age. 3 multiplied by Carol's age. Then we see the sum of their ages. So we're adding together their ages, which were G and C, is 45. And we want to know how old Carol is. So this is not a bad position to be in. We have 2 equations. And in those 2 equations, we have the 2 variables. So again, what we can do here now is what's called substitution. I know that G equals this expression here. And this G here is the same as this G here, which must mean that I can plug this expression in for that G just because that expression is the same as that G. So let's do that. I'm going to put in 5 plus 3C for my G. There we go. And then I'm going to add C to that, and that's going to equal 45. So this represents Gary's age, that represents Carol's age, and when we add them together, we get 45. Now we can combine like terms. 5 plus, 3C plus 1C gives us 4C equals 45. We could subtract 5 from both sides and get 4C equals 40. Divide both sides by 4, and we get that C equals 10. Okay, that would be answer choice A, but that's also a lot of algebra. Here is another way. I could just say, you know what? Let me try out an answer choice and see if that would work for Carol's age, and that'll keep me from having to ever set up anything algebraically. So if I'm going to be super savvy about this, I'm going to choose one of the ones in the middle to start. Why? Because if I choose one in the middle and I find out, say I'm trying B first, and I find out it's too big, not only can I eliminate B, but I could also eliminate anything that's bigger than B, because if 12 is too big, so will 14 and 16 be. And if it's too small, not only can I eliminate 12, but I can also eliminate anything smaller. So let's give this a shot. Let's try 12. What if I said, okay, how old is Carol? Carol is going to be 12. Carol is going to be 12. Now, if I read the problem, it'll give me more information. It says Jerry's age is 5 more than 3 times Carol's age. So I'll know that however old Jerry is, it's 5 more than 3 times whatever Carol is. So we know that 3 times whatever Carol is, that would be 3 times 12, because Carol is 12 in this answer choice. And we'll increase that by 5, and we'll get Gary's age. So that's 36 plus 5, that's 41. Now, how will we check? That's Gary's age. How will we check if that's right? Well, it says that the sum of their ages is 45. So if these are their ages, let's add them up. 12 plus 41 12 plus 41. If we get 45, then this must be the answer, but we don't. We get 53. That's too big. So not only can we eliminate B, but we can also eliminate anything bigger. Now, I often get the question, well, then can I just pick A now since I know the other ones are wrong? And I'm going to say, let's not leave your score up to chance. Let's actually try out A, because what if we accidentally went in the wrong direction? That wouldn't be that fun. So let's just try out A and make sure that we're right. So we're going to say for A that Carol is 12, and we know that Gary's age, whatever his name is 3 times Carol's age, but 5 more than that. Okay, so that gives us 35. Let's check out the sum of their ages and see if it equals 45. 12 plus, oh, sorry, that wasn't 12. That should have been 10. 10 plus Gary's age, which is 35. That gives us 45, exactly what we wanted. So we know that A is our correct answer. So again, the technique for Backsolve means you never have to do this. You start in the middle, and you pop it back in for whatever you're looking for, and then ask yourself the next important question which is what else can I figure out? Usually there's 2 parts to the question as we have here, where the first part gives you more information. Like we take Carol's age to find Jerry's age, and then we test it with that second bit of information to see if it works out. Let's look at another one, a little more algebraic here. You'll see on the next page of your notes the technique, but here's another one to try. So we see J plus K is 9, and J squared plus JK equals 36. Then what does K equal? What does K equal? Let's find out. Well, K could either be 3 or 4 or 5 or 6. So if we're going to try it out, let's start in the middle. Let's start with C this time. We'll say 5. Let's say K is 5. Let's try it out. If K is 5, this K would also be 5. And I know that J plus K is 9. Well, J plus 5 then would be 9. And what do I add to 5 to turn it into 9? Well, I add 4. So that makes J 4. Now, I said my K was 5 and my J is 4. How will I test it out? Well, I have that second equation, which is J squared plus JK equals 36. So let me pop a 4 in for the J and a 5 in for my K, and we'll see if it works. Well, that's 16 plus 20 equals 36, and that is indeed what that comes out to be. So it looks like I just found my right answer. And unlike plug-in, I don't have to try all the other answers. That one was enough, because once I find one that works, I'll know that the other ones wouldn't be the right number to work. It's not like multiple ones can work on this test. Okay. So again, a little simpler than plug-in. Just start in the middle, pop it back in. So, some frequently asked questions about Backsolve. If the first choice you try works, should you try the other answer choices just to be safe? As we said, no. Once you find the right one that works, you don't have to. It's not like plug-in. If you're not sure whether you want to go higher or lower, don't worry about it. If you can tell, great. If it's easy to tell, great. That saves you a little bit of time. If you can't tell, just pick a direction and go. There's a chance that you'll find the answer choice before you've kind of even figured out which direction to go. So don't stress like needing to go bigger or smaller. Sometimes you really can't tell. Just pick a direction and go. So how can you tell if you can use Backsolve on a problem? You can use Backsolve on a problem usually if you're looking for a value, not a relationship, not an expression, but like a number appears in the answer choices. Sometimes you can pop it back in, especially if it's a solution to an equation or something like that. It's a great opportunity to Backsolve. So let's try a bunch of these. So for this first one, we're looking for X. X could be 22, 54, 66, 96, and we're gonna pop it back in and see if it works. So it's gonna go back in for X. So that's that spot in the equation up there is X. And I'm gonna pop in the answer choices and see which one could give me 8/3. So let's go ahead and put in, let's try 54 first. Here I get 64 over 12 equals 8/3. Now, remember, I'm trying to avoid having to do too much math. So what I'm gonna do here, I'm gonna add another window. I'm gonna add my little calculator in here. Hopefully I can find it. Says, nope, that's not it at all. Why is that even open? Jeez Louise. Let's close it. Okay, and let's see if we can add another window here. There's my calculator. Okay, very good. So if we're gonna do this, you know what? This is gonna be, let me just